Welcome back. In our previous video, we got introduced to 2D arrays, which is the topic of this unit. And let's kind of recap some of the things that we did, right? We learned how to make a 2D array. You could either use the traditional construction statement where you kind of pick the number of rows, number of columns. Now, in this particular example, we're using an int 2D array, so it'd be filled with zeros. You could also use an initializer list, and the initializer list clearly shows that in Java, a 2D array is an array. Right here are the outer braces or brackets. In fact, I can add some new lines here to maybe even put in more separation. Right, this is the beginning of the array. There is kind of in essence one array here, but the individual elements of the array are integer arrays, right? The way I like to think about it is this is an array of integer arrays. Okay, so here in this particular case, we are creating we were trying to go with it like a 3x2, but I ended up showing that you can have an array where there's multiple columns in a single row. For that, we call it a jagged array. Now, jagged arrays aren't really in the subset. Every array that you should be encountering in CSA is going to be a rectangular array, which is normally achieved by this. But you can use an initializer list in order to create one of those things. Here, we're just showing some syntax on how you can change the individual elements. And a big talking point for 2D arrays is how do you traverse these bad boys? Here, we're doing that using nested loops. And here we're doing row major traversal. That is, we're going to actually start on a row and go through every column before going to the next row. Right? With each iteration, this loop is going to finish out first, going through all of the columns. See how we've labeled it with a C. And then we would go to the next row. That is row major traversal, which is the one that you should expect the most. It is the best because with the row major traversal, we can actually traverse a jagged array. If we were to flip this and do column major, you got issues potentially. So we're actually going to pick up there. And what we're coding today is getting started on TicTacToe. There's a possibility that we finish, maybe not. But this is what our game is going to look like. So I'm showing you the final output. We see the board, and I've numbered all the spaces. The reason being is that even though in terms of the 2D array, right, this position is like 0, 0. This one is the same row, so 0, 1, 0, 2. We don't want the user to have to input two numbers, right? An XY location or a row column location in order to pick their space. So I've numbered the spaces, which makes it easy. We see that it's player X's turn. Player X is going to say 5, right? They're going to choose a space. Now we could validate this in the actual driver to make sure they're giving us a number 1 through 9. Or we can precondition everything and hope for the best. But we see that player X is now occupying space 5, right? The 5's not there and X is. It is now player O's turn. Player O, let's say, goes 8. And you see that the O now occupies that space. Now, one thing here that we are doing in the driver, or perhaps the actual TicTacToe class itself, is ensuring that a space cannot, we can't override a space. For instance, notice it's player X's turn. Let's say player X tries to go to space 8. Notice that there is no change, and it's still player X's turn. So that is one kind of situation that we are handling. I doubt I probably handle this, right? If we do a 10, it just breaks. That's not a big deal. Let's get started on TicTacToe. So in IntelliJ, I'm going to make a new project by going to File, New Project. We'll go Next. We'll go Next. And I'm going to create the subfolder. I'm already in my CSA, so we're going to do a TicTacToe. And it is creating the subfolder for me. Perfect. Oh, sorry, I'm in my demos folder. I do need to switch folders. I have lied. There we go. Here we're going to make our TicTacToe subfolder. I'm going to expand the project folder, right click on the SRC and make a new Java class called TicTacToe. And right away, we're actually going to bring in some object orientation stuff to it. That is, I'm going to actually use an instance variable. So let's think about this. We know that the board is a 2D array, right? There's an interesting design theory on like what is the actual data type. In the last video, we saw an integer 2D array. That kind of looks like what we got going on here, but we eventually have letters, right? One thought is, okay, we can use strings. That's a little bit closer. Since it's only one, character here, I'm going to end up using a char 2D array. One erroneous thought is that, well, we're just going to fill it with X's and O's. That's only 2 states. Thus, we could actually get by with a Boolean 2D array. Technically, there's 3 states, right? There's an X is in the space, an O is in the space, or neither, right? Some type of number is in the space instead. So there's 3 states per actual space. That leads me to use something. You could use an integer 2D array that's like super wonky, and you end up, changing the values in the toString, right? This could, in theory, just be an integer 2D array behind the scenes, but the toString is making it look correct with the X's and O's, and you're using some, some number other than 1 or 1 through 9. No, just use a char. I would accept a string, but since it's just a single character, I'm going to use a char. Technically speaking, the char data type is outside the subset, but based on what we know about strings, this is an easy thing to do. So I'm going to make a char 2D array, and I'm going to call that board. This is going to be an instance variable in my TicTacToe game. Let's create our constructor. Right, here I have a no args constructor. The idea is, for the most part, our TicTacToe is always going to begin the same way, where we create board, we initialize board, I should say. Board has been declared as an instance variable. I need to actually initialize it. It is going to be a new char 2D array, which is a 3x3. And the reason I say this is what happens for the most part, you could do something wonky. You could try to do like TicTacToe with, a 4x4 or a 5x5. Do not recommend. We basically have one way that the game begins, which is with an empty TicTacToe board. Now, we're creating this char 2D array. They're going to be filled with the default value for char. I wouldn't worry too much about what that is currently. Let's maybe get our toString going so that we can actually visualize this thing. And I'll flip back to our end result, and you'll notice kind of what we have are numbers in the spots. Right? So we have some options. We can choose to loop through this thing and fill it with numbers, or we can kind of let our toString handle the displaying of that. It kind of doesn't matter. Like the only change is where you're putting the work. Are you putting the work in, like, say, the move method? Or are you putting the work in the toString? Okay. What I've done in practice is I just let the default value sit there. And so all of the work is kind of in the toString. But why don't we actually get started on that toString? I want to be able to visualize the board. Okay, a couple of things I recommend here. Notice that we have this line that repeats twice. I'm actually going to make a variable and save this in. In total, that's what? 3, 4, 5, 6, 7, 8, 9, 10, 11 little dashes, minus symbols. So one thing I would do is just create this line variable. And it is 11 dashes. I'm going to end up reusing it. I want to make sure it's a good size. Maybe in the early stages of this, you're not exactly sure how many little minus symbols that you want. And so creating the variable allows you to quickly edit it, and it'll affect multiple places, because whenever I need it, what I'm going to do, instead of reforming the line each time, I'm just going to refer to the variable. Okay, so the variable is slightly big brain. Okay, we're also going to create some type of blank return string here. Right, we're going to end up looping through this board. Keep in mind there's really nothing in it right now except the default value of char, which I'm avoiding talking about what it is, but we'll see it with our toString. But I'm going to end up looping through this board, and we're going to kind of concatenate. We're going to make the string version of the board. All right, I'm actually ready to start looping now that I have this empty string and this line declared. Okay, because it's a 2D array, we're going to need nested for loops. I'm going to use our IntelliJ shortcut syntax for I. It's given me an opportunity to rename the counter variable, which I will do. I'll name it R. All right, we're going to go in row major order. It's what I recommend. And we'll say as long as R is less than board.length. We're now ready for our inner loop. I'm going to use for I yet again. And we'll rename this one C. We'll say as long as C is less than board at R.length. Technically, our TicTacToe board is square. I would stick to the term rectangular, which is also true, as a rectangular board is also a square, which means that we can use R, of course. We could also technically use 0, just asking how long is the first row. However long the first row is however many columns each row has. I highly recommend sticking with R, though, because this particular set of loops, set of headers, maybe I should say, will work for a jagged array as well. That's the biggest upside. Now, we're going to be mostly working with rectangular arrays, so you could interchange the 0. What I would also be prepared for is to know that that works, right? Because this is a rectangular 2D array, that is, each row has the same number of columns. You could use 0, you could use R. Okay, we could also traverse it in column major order. I'm not worried about it. Okay. Let's take a look at our output yet again. And let's talk about what's happening here. First thing I have, right? We're gonna basically tackle this row and then move on. First thing we have is actually a space, right? I want to center up this one. So we're going to go space, then insert a number, space, do a vertical bar, literally what it's called, space, so on and so forth. Okay, so I'm ready. First thing I'm going to do on right here is I'm going to take my return string and we'll add a space to it. I'm ready for the number. Okay. In the future, we're going to detect to see is there an X or an O here, but for right now, it's just the number. One approach that you could do is create a third counter variable. I think this one is a little bit intuitive, right? We create integer I and we start it at 1. So I'm going to insert I. Then maybe increment I, so that the next time we add it on, it is increased by 1. Then we add on yet again another space. So effectively, we're starting the first row. We've done space, the marker number, space. Okay. We're now ready for our vertical bar. One thing I will say is that a lot of this stuff can kind of just be combined, right? I know some of you are probably yelling at your monitors right now. We can go space plus I plus our space plus our vertical bar. Then increment I, right? What that's going to look like is something like space, the number, space, vertical bar. We would move on to the next element and effectively do that again. Right? Space, the number, space, vertical bar. We're going to end up doing it again where we go space, the number, space, vertical bar. Notice that after I finish processing the column, or the row I should say, there's an extra vertical bar here. Okay, I've talked about it in other videos before. One approach, or the two approaches that you can have to this is preventative, or you can kind of roll it back. by the preventative approach, I mean we plug in an if statement and we never add the vertical bar to begin with based on an if statement. The rollback approach is let's add it and then delete it afterwards. Okay, I like the rollback approach in most cases. So after we finish the row, we got this extra vertical bar. I want to delete it. Okay, how do I know once I finish the row? Well, I'm done processing the row once we've done all of the columns. That is, once this inner loop is finished, right here, line 24 for me. We're done with the row. I got this extra vertical bar here. I'm going to delete it. The way I'm going to delete it is by taking our string. Keep in mind that you can't really delete from a string. What you can do is keep a section of the string. So I'm going to keep everything up to this vertical bar, right? Everything but the last character. I'm going to say RTN is going to be a substring of itself, beginning at index 0 up to the length of the string -1. Okay, at this point, this is what our string should look like. All right, we've gotten rid of that vertical bar. I'm done processing the row. If we look back at what we need next, right, I should have this completed. What I need now is this. We preemptively made our line. All we got to do is tack it on. Okay, so we're going to do that over and over and over again, building up our board. Why don't we take a look at what we got so far, right? This is still mad at me. I got a little red error here because we ultimately need to return this string. And I'm going to make a driver in order to get some testing started. We'll right-click on the SRC, make a new Java class called driver. I'll plug in my main method. And I'm going to create my TicTacToe object, which I'm going to call game. And we'll just go through the noargs default constructor. I'll print off the game, which we'll call the toString. I'm going to right-click in free space and tell it to run. And let's take a look at what we got so far. Okay, I got something that looks like this, right? We got some issues. This is looking pretty good. And we got our line, which is pretty good, but we need it to be on a new line, right? After I process a row, I want to create a new line so that this shows up on the next one, and the next one, right? And we'll talk about this right here. I got to get rid of that. I'm going to flip back to my TicTacToe game, right? After we process a row, I need to create a new line using the new line character, the escape sequence. Okay. You could do it right here. Right? Realities is we need to make a new line so that this goes down, and then we can, in theory, make a new line for the next one. You can kind of spread this out. I'm looking at my old code, and I've done something super cheeky. I recognize that I want a new line before I make this, and I want a new line after it as well. And so I actually added the new line character to the string here. Right? By doing so, what's going to end up happening is that we're going to process the row. We'll have this, and then I'm tacking on the line, which will cause a new line, print off these characters, and then make a new line. So whenever I do 4, 5, and 6, they show up on a new line as well. Okay. There's other ways you could have done that. You could spread these things out, but this is kind of nice, just sticking them there with our line string. And then we end up with this. This is a pretty good looking board, but we do have these extra characters here. That is, after we've processed the entire TicTacToe board, I've got these extra 11 characters or so. Okay. Again, we could do a preventative approach, or we could do a rollback approach. I did a rollback approach here. So I'm going to do a rollback approach again after we've done with our board. RTN is going to be a substring of itself. Starting at index 0, that's like way up here, and going all the way to here. right? Think about this one. This one may be worth pausing on and see if you can figure it out. But it's going to be a substring of itself being an index 0 up to the length of itself minus the length of our line. Now you could count out the characters here and kind of figure that out, then plug in some number. But again, by using line, using this variable, I could come in here and fat finger a bracket. I could come in here and like add or subtract little minus symbols depending on what I want my output to actually look like. Maybe, you know, I counted, I knew exactly how many I wanted in advance. And in fact, I actually botched it there. But by using this line variable, it makes for easy editing. It also makes it a little bit more easy to edit down here. Instead of having to count all of the characters, I just reference the length of the line because it is a string. It still looks like it may be a short one. Yeah. And there we go. Okay. So I'm going to revisit the idea I said earlier about whenever we make the 2D array, we could choose to fill it. It just changes where you do all of the work. What am I saying? I would say that I'm doing the work in the toString here, right? This thing actually isn't filled with 1 through 9. There's something else in this char. If you really want to see what it is, instead of using I, let's pull out the element here. The element at our char array, sorry, it's called board RC. So instead of using this little counter variable that I made to number the spaces, I'm going to pull out the current element and print that off. Oh, interesting. All right, this is the default value of a char. It's not what you think it is, right? So my point is the board isn't actually filled with numbers. You could have filled the board with numbers in the constructor, and instead of using this counter variable, you could then pull out the actual value that is there. It just changes where you do the work. That would have been more work in the constructor and less in the toString. Here I'm doing less work in the constructor and more the toString in order to achieve this. Okay. The reason that I like doing this is because when we get to a move method, we're going to actually detect X's and O's, right? But one easy way, instead of asking, is a space an X or an O, we ask, is it basically not an X or an O? Something of that sort. We don't really care what's in the board. Let's get started on that move method I'm talking about. I'm going to plug in a method header here and then Java dock it. So we're going to say public boolean move. In this case, we're going to take in a player that wants to move. And where do they want to go? This one definitely needs some Java dock because we're going to end up using some preconditions here. This inserts player into board at space, space being this integer where they want to go, provided space is available. That is, it's not already occupied. We do have a precondition. I'm going to precondition it so that I don't really have to check for these things in our driver. We're going to assume that player is either X or O. We're also going to assume that space is valid. That is, it's in the range 1 to 9. So the College Board would probably express this differently. The College Board may say something like 1 is less than or equal to space, which is less than or equal to 9. That's the exact same thing as that my precondition just said. Right? Space is in the range 1 to 9 inclusive. So I would just be a little bit prepared for that. Again, for the AP exam, you don't have to write preconditions, but you do need to be able to read them, which is why I even talk about what the College Board would say. We're going to return true if space is available, false otherwise. Okay, notice this thing is returning a Boolean, right? We basically want to return true if it was a successful move false otherwise. This is how the driver is going to know to switch players or not, right? Recall that in my demo, X tried to move into a space that O already occupied, and it just remained X's turn. That decision is actually made in the driver, and this move method is telling it as such. Okay, so what's interesting here is we've numbered these spaces, right? 1 through 9. So I'm just like, haha, I'm going to plug it into whatever space. If we pass in a 5, it's just going to go here. But keep in mind, this is not a 1D array. This is a 2D array. So I have to take this number and convert it into a row column. This is an excellent spot to pause if you were looking for a challenge and see if you can complete the move method. But I'm going to continue on. There's a super big brain approach. I'm going to create integer R, right, for our row. I'm also going to create integer C for our column. But we're going to take that space and divide it by 3. In order to get the column, I'm going to take the space and mod it by 3. Now imagine if you paused and you did this on your own, you kind of recognize that realities are this space is like a 0, 0 location. And so with us starting our numbering at 1, that's going to be slightly off. And so like subtracting 1 out here will help get you there. I'll show you the divide and mod and how it works in just a moment. You could also subtract 1 off the space and get there. You would have to put parentheses around this. But because we're subtracting 1, here's what I actually recommend. Before we do our calculations, let's subtract 1 off the space. Visually, we're going to show it to the user as a 1 through 9 type of situation. Our move method is going to handle it correctly as a 0 through 8 situation. So we're going to subtract 1 off the space. Let's say that the user entered 5. Super common, right? So coming into this, space is 5. We're going to subtract 1 off, which means space is now 4. Right? So when we get to this calculation, we're talking about 4 divided by 3. 3 will go into 4 how many times? Right? What are we talking about here? Sorry. So we do 4 divided by 3, right? We get 1 point something. But what we're dealing with is integers. So truncation is going to occur, which means this is actually going to be 1. So R is 1. So we get to our column, right, where we do space mod 3. Three goes into 4 one time, right? We're going to subtract out 3, which leaves us with a remainder of 1. Okay, so our column is 1. So when I get to this point, my space is actually 1, 1. Okay, does that make sense? Well, yeah, this initial space, right, is 0, 0. And then we're looking at 0, 1. And then we're looking at 0, 2. That's the first column. Next one, row 1, column 0. Row 1, column 1. I'm going to stop talking and just punch in the numbers. So this is the actual row column locations in my TicTacToe board, despite what this is. So this is what we're doing. We're taking a space, which is a integer, and we've got to translate it into the correct number. That's what I'm doing here. So if we enter in 5, you see that we end up with the correct row column, this one right here in the center. Let's maybe walk through the math on a different spot. Let's do like 7. Right, we're going to immediately subtract 1 off, which is a 6. So I'm going to do 6 divided by 3. That's going to give us 2. Then I'm going to do 6 mod 3. Right, let's look at the math real fast. How many times does 3 go into 6? 2 times. We're going to subtract out 6, leaving us with a remainder of 0. So our column is 0, and that is the exact spot, spot 7. So here is the cleverness of this. Now, another approach, if you paused and worked through this on your own, another approach that you might have reached is using the nested for each loops and actually just literally counting the spaces, looping through the board and going, okay, this is 1, this is 2, this is 3. You just keep going until you end up with the space that you're looking for. That is fine. This one's faster and efficient. I'm going to get rid of these comments and we're going to continue on. All we've done so far is translate our space into the correct row column, which means I'm ready to plant my X or O if the spot is available. How do I know the spot is available? If the current location, that is board at RC, is not an X and it is not an O. Notice that I'm using single quotes here. Notice I used them up here because ultimately we are dealing with a character and a 2D character array. So I'm going to check the current location. If it is not an X and it's not an O, that means it's something else. It means it is available. So I'm actually going to plant. Right? I'm going to say that the current spot on the board will become the player. Again, we're turning that spot into an X or an O. We are successful in this case. So we're going to return true. If I manage to make it to line 34, that means that spot was taken. So we're going to return false. Okay, let's try this out. I'm going to flip over to my driver. We got our game, right? So we see the initial state. We'll try a move method. Let's take the game, tell it to move. We need a character. I'm going to plug in an X. We need a space. Let's say 5. I'm going to print off my game after the fact so that we can see that change. So we see the game in the before state. We see the game in the after state. What did I goof on? I was not expecting that. It's grayed out. Am I not calling it? I am calling it. I am very confused. I'm going to print out the result. That was one thing I was going to get at anyway. Oh. I need to update the toString. Now that we're actually planning X's and O's, it's possible the space is something else, right? As we're looping through, right, we're forming our board. Let me get rid of these comments. So in the toString, I'm just filling the spot with the number regardless, but we actually should do some detection, right? Whenever we begin the kind of the row here, we're going to start with our space, and then we're going to put the little space marker if it's not an X or an O, which means I need to plug in an if statement in order to detect that. What do I mean? Well, the space is going to be there regardless. Regardless of if the space is an X or an O or not, we're going to begin with a space. I'm going to do the detection here. How do I know? Well, if board at RC is equal to X, I should say not equal. If it is not equal to an X, and board at RC, you could have copied this from above, does not equal a O, then that means it's something else. I showed you earlier basically a blank board. I believe that space is like a tab or enter or new line, something like that. Doesn't matter. If it is not an X or an O, I'm going to use this little marker, right? I'm going to use the
counter variable. So we'll say plus equals I. Okay. Otherwise, that means it is or an X or an O. I don't care which one it is. We're going to add it onto our return string. So if the space is available, we'll use the counter variable, the little spot marker. If it's not available, meaning it's already occupied by an X or an O, we'll plug in the X or the O. Regardless of which one we plug in, we're going to end the row with a space vertical bar. Let's try that again. My move method was working. We just couldn't see it. Aha. So here's our board initial state. True. We are successful in planting the X into space 5, and we visually see that. Okay. Let's try putting an O into space 5, which should be occupied. So I'm going to print it off. We should see a false value, but I'm going to print off the game again so that we can see that there is no changes. And we'll actually follow the flow of that. So here's my initial state. We then perform a move where we put X at space 5. We print this off so that we can visually see that. We then try to move O into space 5. Well, that spot is occupied, so I get a false value. Right? Whenever we call the move method here, we're going to jump to the move method. We'll subtract one off our space, translate it to a row column, and then we're going to check that particular spot. It should be this spot. We're going to ask, is it not equal to an X? That is false. I have false in something. Doesn't matter what that something is. This whole expression evaluates to false. We would skip over this and just simply return false without trying to plug in the player. So this is going to be a good spot to stop. We'll pick it up in the next video where we finish out our driver, which will alternate between whose turn it is. And we'll also write a game over method in order to know when to actually stop. I'll see you then.